Hello, I'm Andrew Smith from the Open University Cisco Academy, and this is the last in this series of short recorded lectures or webinars. And I'm going to be exploring Module 17, Build a Small Network, from the CCNA Introduction to Networks. Now, I'm going to talk about this because there are some great packet tracer activities in this module that is going to encapsulate everything that you've covered, and it's going to help you develop your troubleshooting and networking skills and build you towards the switching, routing and wireless essentials. So it's one of those, you should do it. Really, you should do it. In fact, you must do those packet tracer activities. As I've always done, I'm not going to read slides out verbatim. You can see what this is about, and you can see a lot of this is about troubleshooting, using ping, using traceroute, using show commands and other things to explore and discover faults on a network, and basically build up a good troubleshooting mentality. Okay. I mean, from a CCNA perspective, you're going to be working on a small network topology for the time being. As you develop your skills, you'll be working on larger and larger and larger. And it's about building that, what's the local problem? What's the remote problem? What's the problem at scale? Is it me locally? Is it on my own infrastructure? Or could it be beyond the veil, beyond the router or the domain of control that I have? And I mean, they give examples here. Small network design is usually simple. Well, maybe, but nowadays with IoT devices and many other things, infrastructures are constantly expanding, and we have a lot more devices on wireless that we may not have known about in the past. And people don't realise that often wireless passwords, WPA, whatever passwords, are being passed around, and they are capturable as well. So you've got to understand what a small network or a topology is, or what your domain of influence is, and where you can actually do your testing. I mean, device selection for any network is based on what you can actually afford and what services does it offer, and what capacity do you have for growth, and what are the features, what can you learn, what can I secure, what can I run, what it is I'm looking for. And nobody is going to be building a network from scratch nowadays. As I said, this is very rare. It's about how you extend, integrate or develop an existing network infrastructure. And that way you sort of look at what kind of router or switch or firewall or whatever that you actually need. And when you're actually doing that, you've just got to look at the addressing. How does it scale? How many people am I likely to use? How many wireless access points do I have? And I was talking to somebody yesterday. They were in a well-known centre nearby, run by a well-known university, not ours. And they had 50 students in, and the Wi-Fi couldn't cope with the fact that they needed 50 students with 50 laptops with 50 simultaneous connections running within a challenged cybersecurity activity. And you think, should that not be able to do that? But they just hadn't scope for that. They scope for ordinary users, probably using email or Facebook, and probably no more than a certain number of users at any given time connecting. So you can see a little bit of a scoping problem there. So what is your environment? What is the maximum likely use to be in any given situation? And it's like explaining to a chef catering. Catering is fine if you've got fine dining where you've got 10 or 20 people, but if you've got a mass function of 200 people, that completely changes the dynamic. I know this because my son was a fine dining chef and worked in the world of Michelin. And you can do the really clever stuff for a certain number, but since it scales out, you can still be clever, but it's differently clever. And some of the things you could do for 10 or 20 sittings is not going to be the same as 200 or 300 sittings, especially if all those people want to be fed the same course as almost So thinking networking in those terms. If you've got that small bijou bespoke network that's got a small number of users, you can do something completely different in scale and resource than you can for hundreds of thousands, especially if there's going to be a lot of people using that network simultaneously at any given moment. So we need that redundancy, we need resilience, and you will learn about multi-layer switching, you'll learn about spanning tree, you'll learn about hot standby routing protocols, you'll learn about load balancing, and basically we want to have multiple devices that will actually handle it. So if one of them fails or one of them is overloaded for security or performance reasons, then the rest of the network should cope. Air quotes here, should cope, because obviously there are sometimes unforeseen surges or challenges, and what we want is the right quality of service, the right prioritization, and the right levels of demand, so that the right traffic's getting through and we've got the right performance. I mean, at the end of the day, most of the time, most networks perform quite happily and nobody ever notices. It's only when we've got connectivity issues that we actually see that we've got demand problems, but seldom in the corporate network, probably more in a public Wi-Fi 4G, 5G environment, and then that's when you have to prioritize what is it that is the most important service. And it's not your videos on YouTube of fluffy kittens, I can assure you. So in small networks, you've got to actually work out what the applications are that you are going to prioritize, what the applications are that you are going to ensure have reliable service on your system. Here is an example that we've covered in many presentations before. These are likely to be the likely services that you're most likely, if I say likely again, likely to want on your network, or the ones that Cisco are covering on this course. Also, you need to be aware of what your corporate network environment requires. You need to be aware of the services, the clients, and the servers that are operating. And as I say, a server could offer multiple services, and I gave an example of what could have been multiple services, and I split it out amongst three servers, so that you could actually see what I was doing and how I was doing it. And that way you should then understand with the common protocols, what are the things they're doing, what are the messages they're sending, and what do I need to actually allow, and what should I possibly block, especially if I want to set up some domain segmentation. I need to, if I've got VoIP, and most people have got VoIP now, most people are using Teams now, which is actually technically is VoIP. I mean, it's actually based on the kind of technology that Skype used around reliability. So it does use scavenger traffic. But basically, what's the infrastructure? What's the reliable service? Do I need voice on demand? Do I need video on demand? Do I have real-time applications in manufacturing, in critical systems, control systems, security systems? And do I ensure that those have priority over the online coffee machine, for example? Okay. And what's our ability to scale to larger networks? So as the network grows, or the network integrates with other networks, which is more commonly the situation, then it's got to be able to scale or evolve or integrate. So being bespoke or being unique is, not going to happen, never happen anymore. And naturally for any organization, growth is about the change in technological requirement and technological footprint as well, and through acquisitions, mergers, or other required business opportunities. And that way then you need to know what your peak utilization is, using protocol analyzers, using different tools that are available within infrastructure to analyze your network performance, and understand what it is that your employees are doing, how are they hammering your services, and is it a 9 to 5 service? that's on site. Now, obviously, we're mainly hybrid workers. What are the remote services that people are requiring, and when are they accessing them? Because obviously, with hybrid working, people are working out of pattern a lot more than when this slide was written. So, and there's a little bit of repetition here, and you've seen this, turn up in other slides. And it's all about ping. Ping near, ping far, ping in the middle. Ping yourself, your loopback, ping the default gateway, ping something remotely, and see what the connectivity issues might be. We've got on Cisco routers, a exclamation mark means that it's worked, a dot means that it hasn't worked, and a U means it's unreachable. Okay, and obviously ping on a desktop system will give different messages out, but this is on a Cisco router or a Cisco switch even. But what you're probably not aware of, and I did briefly mention this, is called an extended ping. Type ping, hit enter. It's default IP. You can change it IPv6. You've got the target, but you can change the source IP, and you can say, I want it to come out of this router or switch interface. Okay, or if I want to set up a loopback and I set it out of that interface, then I can say this pseudo network. So I'm going to test if access control lists or this is being routed or route mapped or prevented. And you can then say the size of the packet or datagram, and you can also say how many. So rather than the default 5, you can say, right, now I want 100 to go through. So I can sit back and watch the performance across the network and packet snippet and other things. Okay. Trace route, remember, is like ping. It uses pings, but it now pings off of each hop and reports back each hop in the path as well. And basically, trace route or trace RT is a command that is used across desktop and different operating systems. It's Control-Shift-6 to stop it in a Cisco device, or Control-C in a Windows or other devices as well. But there is also the ability to, oh, you go, see, I've mentioned it. There is also the ability to use what's called an extended trace route, where you can actually give it other vectors, other parameters to sort of consider as part of its performance. So you can actually change the timeout or the source addresses coming from, just like an extended ping on a Cisco router. There is an extended trace route on extended router as well, where you can say what source or loopback are things and see which way traffic is traveling around the network, especially if you've got a multi-port router that is load balanced off to different routers and routes on the network. I'm going to take a sip of my coffee before moving on to the next slide. Well, the important thing is to establish a network baseline. What is it that is actually the likely performance of a network? Look at the network when it's quiet, look at the network when it's busy, look at the network at 9 a.m., look at the network at 5 p.m., look at the network at lunchtime when colleagues are busy looking at videos of fluffy kittens, and start getting a view of the performance and the behavior of your network. And of course, there are many tools to do that. Obviously, we're now going to be covering on these slides a range of common commands. You see it's talk about Windows 10. Well, we're actually moving over to Windows 11 now, but these are slightly old slides, but these commands still work, and you can actually look whether it's ipconfig or ifconfig on a Linux device. You can look at the current settings of the environment, and you can release and renew DHCP addresses. And you can actually do this on Packet Tracer as well. It's got a IP config. We're releasing really new. The PC on Packet Tracer is a pseudo Windows machine. There's obviously many of you that's the common device you would use. Obviously, I've mentioned ifconfig. What I would highly recommend if you've never done it is sign up for the Linux Unhatched course. We actually, for TM257 students, offer this content on TM357 as a refresh because there is some Linux requirements on the DevNet course at this present time, and we actually put in the 8-hour Linux Unhatched course as a refresh reminder because we know that you've covered some of this on TM129 where you have done the Networking Essentials CCST networking content. But the ifconfig, like ipconfig, is very similar. And obviously I am a Mac user, and you also use the ifconfig. There is what's called a terminal session, and you can just open up the terminal session, which is a Z shell, and then you can actually go in and administer it accordingly. I mean, they're using some commands that I think are just a little bit over the top because ifconfig will work as well. Arc works on all devices. We've looked at the Arc cache before. Arc-A tells all. It's basically a host table and will tell me what it has connected to my device. Then you've got the show commands, and you can do show IP interface brief, show run, show interfaces, IP interface, and root and protocols and version, and so much more. Okay, what I will advise is just get used to the fact that there are so many show commands and you'll discover them over time. You will not memorize them all. What you will learn is the common ones like show run, show IP interface, brief, show IP root, and then you'll start learning the other ones as and when you need them, like show tech support, for example. Go and try that one out. It is quite an interesting reveal. And you can also use the show CDP neighbors. If CDP hasn't been disabled by default, the CDP is a layer 2 protocol that announces connected or adjacent Cisco devices. It should actually be switched off. Okay, but now you can actually turn it on, and it's a good way of discovering other devices on the system. And it was designed originally just as a way of enabling Cisco devices to talk to each other and discover what's on the network. And then if they can see each other, you can start setting up your routing information. Okay, and by doing that, it's helpful, but they do advise nowadays that should be switched off by default. I've talked about show IP interface brief. Here you are able to get a list of the interfaces and if they're up or down, and any IP addresses that are set or not yet set on them. And it's an excellent summary command. So you can go to a device remotely, do show IP int brief, and then discover what's on it, what it is, and basically already build up a mental map of its configuration, because you can then work out where the next branches of the topology are. So I would recommend you do the packet tracer and do the interpret show command output, because you can do show commands blind, for want of a better phrase, and be able to draw a topology of a network without actually seeing the topology. Troubleshooting is a skill that comes through experience. It is not a book learned skill, it is a practice based skill. Okay, there are lots of ways of handling, and my advice is, once you've identified a problem, work out what the theory is, but actually it's not a theory, it's a hypothesis. A theory is a proven principle, like the theory of relativity. A hypothesis is a consideration until it's proved or disproved. And once you've got your hypothesis, test it, and then if it's proven or disproved, then come up with an action plan, and then implement the solution, check the solution, and detail the outcomes. So what is the problem? What is the probable hypothesis? Have you tested it? If it's been proved, what do you do about it? If it hasn't been proved, go back and come up with a different hypothesis. If that hasn't been proved, come up with a different hypothesis, and so on. And it's important to think in those sort of looping terms. What's the problem? But the important thing is, did you correctly identify the problem? I get people who will still say to me after 30 years, the network's not working. Yes, the network's not working. It is working. It's your connection's probably not working, and then you go through all the steps from first checking if it's switched on, the right port is there, the right IP addresses, the right interface, the right subnet, the right settings, until I move then. Once I've established that all is well on the device, I'll go to the router and look at that. That doesn't mean I won't go back to the device. Once you've moved on from something, don't be afraid to go back to it, because it might be that the problem's still there, and it might be the problem was also somewhere else as well, and it might be a two-stage or two-phase or two-part problem. And it's whether you can resolve it or whether you need to escalate it. Okay, if you don't know the answer or it's beyond your domain of responsibility, escalate. And time again, I've had this with my internet service providers, and I'm telling them what the problem is. And because they're running from a script, they're not listening. But I say, right, you need to send a network engineer out, and she or he needs to go and look at X, usually the cabinet, and blah, 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 blah. And then, a few days later, the engineer appears. I chat to them. They totter off to the thing. It's like, yeah, you were right, and something else as well. Which proves, I have an idea that it can always be something else, but it's beyond my domain of authority. I can't go into the local street cabinet and start fiddling with it. Apart from the fact that it's illegal, it's not my domain or responsibility, but I know sometimes where the issue lies, and you've got to work with others to actually solve the problem. There are a range of debug commands, and what I will advise now for fun is you can do debug all, but my advice is do the undebug all command first, and then run that, and then type in debug all, and then you'll see a lot of information flying. Then hit the up arrow, hit enter, and wait. Okay, because if you want to trash somebody's router, run the debug command. However, it is useful to sometimes debug routing protocol information, or crypto information, or authentication information as well. But you can run debug all, but first run undebug all. Then once you run debug all to stop it, you're going to be blind, there's lots of information flying out. Hit the up arrow, hit enter, and just wait for it as it basically buffers out. But it's quite a useful tool. Obviously, if you just run debug question mark, you can then see all of the debug options. But here, this example shows a debugging of a output, and you can actually also use the terminal monitor and watch the sort of different messages and different communication that take place from a sort of debugging perspective as well. So it's quite useful. It gives you the output and helps you to see any system messages as a log message. And if you've got SNMP, Simple Network Management protocol setup, you can actually set up a logging server and actually send all of these messages to a logging server as well. So finally, there is a range of different practical troubleshooting scenarios which you will actually explore as part of some packet tracer activities. And I would advise you, I'm not going to talk through each of these slides because basically you can read them quite comfortably yourself. You can even pause the slide deck or the video. But basically, there's a set of troubleshooting scenarios, and these two packet tracer activities, the connectivity issues, activity from packet tracer will enable you to look at logical routing or network protocol connectivity and physical cable or IP interface issues as well. So I spent the last 25 minutes waffling on. Do the practicals, do explore some of the commands that I have discussed here, and do develop experience of building networks and network troubleshooting, and be aware that the problem isn't always where you think it is. So build a hypothesis and test that hypothesis and see that it is either proven or disproven. So thank you very much. I'm Andrew Smith for the Cisco networking team at the Open University.